Hi, physics students. So all we did today was take our Unit 5 test, but before we did that, I wanted to go over our last warm-up problem because it was important to understand energy dissipation or more energy out of the system, because energy is never actually lost or it never disappears or goes away. It just transfers. And in this scenario, it transfers out of the system. So let's go ahead and first read through the problem. And as we're reading through, I'm going to write down the givens. So the first thing is we've got a mass of 30 kilograms. We've got a slide that is 4 meters, so that's a height. One thing I encourage you to do is when you see these values, I want you to think about what energy is involved. So if you have a height, you've got gravitational potential energy there. Last, we've got velocity, which is 5 meters per second, and that would be kinetic energy. And then if you read this question carefully, they also state that there is friction, and friction is the key thing you look for when you understand that there is thermal energy. So I'm going to write that down as well. So in this scenario, we've got a child who starts at the top of the slide, no motion, so no kinetic energy, all gravitational. And in this system, I'm going to include the child, the slide, and Earth. Especially since there's gravitational potential energy, you definitely want to include Earth because that's what creates the gravitational potential energy. In the end, we end up with some kinetic energy. So I'm going to show 3 blocks of kinetic energy and some thermal energy. And since I started off with 4 blocks, I have to end with 4 blocks. Now, one thing I want to note, I don't really know if there's more kinetic energy than thermal energy. If you wanted to make it half and half or more thermal than kinetic, as long as you show that there's both energy types in the final scenario, you're fine. And also, you want to make sure that however many blocks you have initial is the same total amount of blocks you have final. What I want to talk about, though, is there's another way to represent this. Thermal energy is also considered energy coming out of the system. And so if you wanted to, you can represent thermal energy as energy coming out. And that means you would drop this energy type right here. So either one is fine. They would both be correct on the test. Next up, I want to talk about the equations that you would use for these. So if we kept it just like this, the equation that represents the child's energy at the top and the bottom of the slide, I'm just going to do this question up under the LOL chart. I think it's easier visually. So my gravitational potential energy is mgh, and my kinetic energy is 1/2 mv squared. Now, I don't have an equation for thermal energy, but I'm just going to write it in there as THE. And based on conservation of energy, I know these two must be equal. Now, since we don't have an equation for thermal energy, the way you solve for it is this is whatever is left over once you've calculated mgh and 1/2 mv squared. So go ahead and do that. I've got a mass of 30, gravity is 9.8, height is 4, and I've got 1/2, again, a mass of 30, velocity of 5 squared. I'm still going to add the thermal energy in there. One thing I want to emphasize is you cannot cancel the mass here. And the reason why you can't cancel the mass is because you're adding thermal energy to this side of the equation. And the only time you can cancel mass is if you can divide the mass out of both sides, but because of this thermal energy, it's not able to cancel out. So let me go ahead and do those calculations. I've got 1,176 joules on this side. I've got 375 joules for kinetic energy and thermal energy is whatever's left over. So the energy lost, energy dissipated, or actually energy transferred out of the system due to heat is what I'm solving for here. I'm going to subtract the 375 to both sides because whatever answer I get here, 801 joules, is going to be the amount of thermal energy that is dissipated to heat during this process. So my answer for this question is right up here. All right, this should be enough to get you to understand the questions involving energy transferring out. Sometimes they use energy loss, which energy is never lost, it's just transferred, but it's transferring out of the system. Sometimes they use the word just like this, dissipated. But remember, energy is never lost, it's just transferred. It can transfer into the system and out of the system, but energy never disappears. All right. Good luck with studying for the test. If you have any questions, feel free to contact me.